My name is Akbar Karimi, and I'm from University of Parma, and I'm going to present two simple modules that we add to the BERT architecture to improve its performance on aspect-based sentiment analysis task. So first, I'm going to introduce the problems that we tackle, and then there is a short description on BERT, and after that, I'm going to talk about the proposed module, and then in the end, we will see some results. So aspect-based sentiment analysis can be divided into several tasks. One of them is aspect sentiment classification. In this task, we want to classify the sentence into three main classes. So, for example, imagine that we have a product and we want to understand how people are thinking about that product based on the comments that they have posted on social media or they have written on a review form or something. So we classify the comment into three classes, namely positive, neutral, or negative. Then the second problem is aspect extraction, which is the extraction of the target of the sentiment that we extract in the previous task. Here you can see three examples of aspect terms that we can extract from the comments. For example, in the second example, we see patterns, and the goal of aspect sentiment classification is to understand whether this is positive, negative, or neutral. And the goal of aspect extraction task is to extract the word patterns from the comment. So we deal with these two problems in aspect-based sentiment analysis. Now, in our work, we use the BERT language model, which has been trained on Wikipedia and book corpus datasets with the masked language modeling method. In MLM, we mask, like in BERT, they mask 10% of the input, and then they train the model to predict the masked tokens. So, and in the end, we have the embeddings for each token that we can use for downstream tasks. The BERT model that we use is the BERT-based model, which has 12 transformer layers. And we analyze the performance of each layer on the tasks that I mentioned. For the initialization of our models, we use post-trained BERT, which has been post-trained on restaurant and laptop datasets. The general BERT has the knowledge of Wikipedia and book corpus, but in order to tackle problems that deal with a different domain, it is useful to have a model that has seen those data, and here we use the post-trained model for restaurant and laptop datasets. Now, we can see that the performance of each layer here in this figure, as you can see, the lower layers perform poorly, and as we go deeper, the upper levels, the upper layers perform better than the others. So based on two different architectures in computer vision, we decide to analyze further the performance to see whether we can improve still the results using the hidden layers of the BERT model. Now, the first model that we introduce is hierarchical aggregation, which is based on feature pyramid network in computer vision. What they do is that they use the hidden layers in a hierarchical manner to do prediction. We took the idea from this network, and introduce hierarchical aggregation, which is applying a BERT layer to each hidden layer and then aggregating the result with a new BERT layer. Then in the end, we apply a linear layer to classify, to get the loss of each branch, and finally we sum all the losses to get the total loss. Then the next model is parallel aggregation of branches, which is simpler than hierarchical aggregation. And here we simply just apply BERT layers to the hidden layers of BERT, and then a linear layer. In the end, we do summation of all the losses in each branch. It's also worth noting that we use conditional random fields to tackle the problem of aspect extraction, because the way that we formulate aspect extraction is by labeling each token. So imagine that in this example that we have here in figure 6, laptop has a good battery. We want to extract battery, and so we label it as part of the aspect that we want to extract, and the other tokens are labeled outside of aspect term. And due to its sequential nature, conditional random fields can help with aspect extraction. The data sets that we use are from Semival 2014 and 16 data workshops. We test on laptop and restaurant data sets, and use the official scripts to evaluate our the performance of the system. Now, we compared the results with two baseline models. One of them is the post-trained BERT that I mentioned before. The other one is the BERT model trained in an adversarial manner. And as you can see here in the results, both models outperform the baselines, but hierarchical aggregation performs better than parallel aggregation in 3 out of the 4 tasks. And the reason is that when using hierarchical aggregation, we share the knowledge between the layers, and this helps better in the performance of the model. So here are the references that you can refer to if you have, if you want to delve into the research. And I thank you very much for listening, and I'm happy to take questions.